loud note.
and a loud note. So
Yes, sir.
which property controls the loudness of your sound waves?
Mm, I think it's tone.
It is
I think it's tone if it's not pitch.
no, not at all. It is the amplitude of your sound wave. The loudness of your sound is the amplitude of your wave. And what property controls the pitch of your sound? What is it?
Yeah, I don't think we've touched that part yet, sir.
It is your frequency. Your frequency controls the pitch of your sound. And and the amplitude controls what do you call this? Your amplitude controls the loudness. Have you guys done electromagnetic waves yet at school?
Mm. Yes, sir.
Have you?
Yes, sir.
Okay, so what are electromagnetic waves? Okay, I'm going to touch a bit on electromagnetic waves. So I'm going to put 2 questions on waves, the waves that you have done so far. Then we're going to do them. Okay, let me share the screen. Okay. Electromagnetic waves consist of the electric field or the electric waves that resonate or that oscillate at a 90-degree to the magnetic field or the magnetic field waves. You don't remember that one?
No,
And
no, sir.
they both travel at a speed of what?
3 times 10⁸
That's perfect. Okay. And how are they generated? They
Or
are
magnet.
generated from a moving charge. A moving charge induces an electric field that oscillates at a 90 at a right angle with an induced magnetic field. So as soon as a, a, a charge starts moving, it creates an electric field.
Yes, sir.
So let us start with the questions. Ndikadiva classini ndikufunza okobyanga mgivero sharp. Okay, sorry for that. The first question, okay, the type of electromagnetic radiations are arranged according to the frequency in the table below. You remember we have talked about the electromagnetic waves, right?
Yes, sir.
And we said Gamma rays are the most dangerous electromagnetic waves. Why? Because they have a higher frequency. The higher the frequency, the more dangerous the waves could be. And electromagnetic waves, what are they? Are they longitudinal or transverse wave? To start
transverse.
Yeah, transverse wave. Why are they transverse? Or let me ask, what are transverse waves?
There are waves consisting of electric field and magnetic waves moving at a speed of 3 times 10 to the power of 8.
Transverse waves have particles moving at a right angle with the wave direction. You got it wrong. This is the definition of a transverse wave. But an electromagnetic waves have two transverse waves that resonate, that are moving at a 90 degrees to each other. EM, they have two transverse waves. Namely, the electric field wave and magnetic. You agree?
Yes, sir.
And they move 90 degrees to each other. At a speed of 3 times 10 to the power of
8.
8 units. That's the speed. Okay, I think we are in the same page. Electromagnetic waves are transverse waves. Why? Because the EM waves consist of two waves: electric field waves and the magnetic field waves. And both those waves have particles that are moving 90 degrees with the wave movement, both of them. Now, how are electromagnetic waves generated? 3.1. A moving charge creates an electric field. Electric field wave that induces a magnetic field wave. And the two move 90 degrees to each other. Okay. The second one, what type of electromagnetic radiation has the highest energy? Kumis. Which one has the highest energy?
Isn't it gamma rays, sir?
Gamma rays, perfect. Why?
Because they have the highest frequency.
That's correct. Gamma rays, highest frequency. Okay, 3.3. Let's see. Explain your answer. Oh, okay, you've already explained. They have the highest frequency. You can even write the formula. What is the formula, Kanen, for energy? Energy of the wave. You remember? You remember this one?
Oh,
which
yes,
has
sir.
which has the, what do you call that constant? Planck's constant. Okay, fine. 3.4. A certain type of electromagnetic radiation has a wavelength of 600 times 10 to the power of minus 10 meters. Identify the type of electromagnetic radiation by performing a calculation. Where do we start? Kumisa, where do we start? Okay, I'm going to read the question again. The question says a certain electromagnetic radiation has a wavelength of 600 times 10 to the power of minus 10. Identify the electromagnetic wave. How do we identify it?
I think it's going to be E is equals to, oh, I think we're going to use the formula of E is equals to H times F.
H times F, okay. And then do we have E? Do we have E? No, we don't. Do we have H? Yes, we do. Do we have frequency?
No, sir.
Okay. So do you have the speed of the wave?
Yes, sir.
Okay. The speed of the wave is given by what?
3 times 10 to the power of 8.
And the formula? I don't know if you agree with me. Am I right?
Yes, sir.
Yeah. So when you're dealing with EM waves, these are the two equations that must be in your head. The two equations that must always be in your head. C equals F times lambda, and the E equals HF. We can actually arrive to the answer, to the right answer by using this one, né? But it's gonna be a bit longer. For instance, your let me not start with it now. Do we have C? I think we do. So I'm gonna use this formula instead. C equals lambda times frequency. So your lambda is 600 times 10 to the power of minus 10 times what is the frequency? Kumisa, do we have the frequency?
No, sir.
That's what we are looking for, so that we can go back to the table. You agree?
Yes, sir.
If we get the frequency, we will have the license to go back to the table and check which one. Do we have C? Kumisa, do we have the value of C? The speed of the wave,
Oh, yes, sir.
which is how much?
3 times 10 to the power of 8.
You see, Skabil, we have the frequency. Okay. Frequency is going to be equals to, we will just divide both sides by 600 times 10 to the power of minus 10. 600 times 10 to the power of minus 10. This will be 600. The 2 will cancel. 3 times 10 to the power of 8 divided by 600 to the power of minus 10. You have a calculator?
Yes, I'm calculating it right now.
Okay. I think we have about 5 times 10 to the power of 15, right?
Yes, sir.
The units?
Minutes per second.
Per
Oh,
second.
hertz.
Per second or? Hertz. But this is this one is the one that is commonly used. So we have 5 times 10 to the power of 15. So what do we do? I think now you have the answer, because they said identify, just identify the electromagnetic radiation. What is it?
Isn't it ultraviolet? Light. Is it visible light?
Yeah, Unyansil. Unyansil. Yes. Yeah. It's UV. Okay. UV rays, and they said state one application of the type of radiation identified in question 3.4.1. Where do we use ultraviolet radiation? Where do we use UV rays?
Isn't it used for medicine?
Yeah, they can be used for medicine. They are used to kill bacteria, to sterilize.
Yes, sir.
You must go and read all the uses. I think they're there in your textbook. You might, that should be your homework for tonight.
Yes, sir.
You must read all the uses of all your radiations. So they are used to kill bacteria in medicine, like to kill bacteria or sterilize. medical equipment. What is the use of infrared?
It's used in remotes.
Okay, infrared used in remote. And this should be Mashlatsi. Okay. And what are the uses of visible light? I think this one is very simple and straightforward.
Isn't it used for projection?
Visible light. This one has a lot of uses. I mean, you can name any use. I mean, for lighting at home also, for your TVs, it's a lot of uses. Visible light is the light that you know.
Yes, sir.
Yes. All right. And then what are the uses of gamma rays?
It can be used to penetrate objects.
Yeah, they're also used to disinfect, to kill bacteria as well. And you said they're also used for
to penetrate objects.
Okay, that can be a bit vague. I think you must find a straightforward solution. Okay, let me just write. They're also used to sterilize, kill bacteria. Sterilize, okay. But if it's there in your textbook, I wouldn't disagree with it. Okay, let's move forward. The second question: the speed of sound in air at 20 degrees is 347. Now, before we move on, why is it so important to mention the temperature of air? Who missed?
I don't think I know, sir.
Okay. If you decrease the temperature of the air, your air tends to freeze, meaning its density increases. It increases with decreasing temperature. So the more you increase the temperature of air, the lighter your air becomes. So like we have said before, the denser the material, the faster the sound wave. You remember?
Yes, sir.
Let me write it down. The denser the material, the faster the sound wave. Okay, so we will have, let me try. Mashlatsi was trying to join the meeting. I don't know what happened. Okay, so between water and air, which one has the highest speed of sound?
It's water, sir.
Why?
because it has a speed of 1,500 miles per second.
That's not the good answer. The answer is water is denser than air. We won't give you the marks if you write that. Believe me. Okay, water is denser than air. That's why the speed is also greater than the one of air. That's the answer. Okay, now let's get into the content now. The speed of the sound in air is 20 degrees. In 20 degrees is 343 meters per second. They said calculate the wavelength of the sound wave with a frequency of 18 hertz. How do we start? Before you start anything, you need to identify the formulas. The best way that you can use to identify the formulas is to put symbols on your magnitudes. So this is your speed. Oh, yeah, this is your speed. The symbol of your speed is V mostly.
Yes, sir.
And you are given F. So you have V and F. Which formula comes to your mind? Calculate the wavelength. Which formula comes to your mind? A formula that has wavelength and V and F. Which one is it?
I think it's going to be wavelength is equals to V times F.
V equals,
as I said,
right?
Wavelength. Oh, yeah.
Yeah, I think that's the formula. Okay. Now, given that that's the formula, we have the frequency of 18 times what is lambda? We don't have lambda. That's what we are looking for. You agree?
Yes, sir.
Is equals to 343. Lambda will be 343. I'll divide both sides by 18. And I will get 343 divided by 18 is what?
$74.6.
74.6. What is the units of lambda?
Minutes per second.
Lambda is a wavelength. It's a length at the end of the day. Lengths are measured in meters. Meters per second is a speed. That's your V. You agree?
Yes, sir.
Yeah, so don't forget the units. Okay, the next one says calculate the frequency of sound waves of a wavelength 3 meters. Take the speed of sound in air to be 330 meters per second. How do we go about this one? Which formula?
Isn't it going to be F is equals to V times wavelength?
Yeah. Have you noticed that we're pretty much going to be using one and the same formula throughout?
Yes, sir.
There's no change. I think this is the formula, right?
Yes, sir.
But we are given the wavelength and also the speed. They want us to calculate the frequency. So like you said frequency equals V over lambda. I agree with you, which is 343 divided by lambda is 3.
I think we were given the speed as 330.
Is it? Let's check. Oh, 330. You're right. 330. 330 divided by 3. 11. No, 110.
Yes, sir.
Okay. And the units?
Hertz.
It's okay. Perfect. Let's go to the next question. Longitudinal waves in a spring have a wavelength of 25 centimeters. What is it that we are given there? 25 centimeters, that is?
The wavelength,
Which is?
25 centimeters.
Lambda, 25 centimeters. Okay. If the frequency of the vibration of the spring is 50 hertz, what is it? Frequency, sure. Then they said calculate the speed of the wave. These people are playing with us. Okay. So again, same thing. There will be times whereby they will give you a period of the wave. This is what you're gonna have. I think you are very much familiar with the relationship between frequency and the period.
Yes, sir.
Okay, then we are sorted. So they are looking for if the frequency of vibration, calculate the speed of the wave. So this is going to be what is lambda?
25 centimeters.
And what are the units of lambda?
Meters, sir.
Okay, we have 25 centimeters. What do we do then? Do we put it as it is, 25?
No, sir.
We
We
divide by?
we divide 25 by 100.
Perfect. So this will give us what? Let's see. 2.5 times 5. Okay, what do we get?
2.5 times 5, sir.
0.5 times 5. So 12.5, ne?
Yes, sir.
And the units?
Meters.
Huh?
Oh,
So when you're running, you can run 50 meters as your speed.
Oh.
The units for speed is what? The units for
Miles per
speed is
second.
meters per second.
Yeah.
Don't forget.
Yes, sir.
What is the unit for frequency?
Hertz.
Hertz. What is the units of period? Period. Period of the wave. What are the units of the period?
Yeah.
It is seconds.
So,
Okay. Let's do this question quickly. Then I think we would have done a lot in waves. So I'm going to add this question. Okay. Okay. We have this question. And the next thing is, okay, let's see. Refer to the following sketch of a longitudinal wave where the frequency of the wave is 50 hertz A, B, C, and D are points on the wave. Now, calculate the time that the wave takes to travel the distance AB. Where do we start? We have been given the frequency. Where do we start, Command?
I think it's going to be period is equals to 1 over F.
Period is equals to 1 over F. That's perfect. Whenever you're given a frequency, you must change it to period, and the relationship is 1 over the other. Now, calculate the time it takes to travel A, B. That's one wave. This is one wavelength. Do you agree with me?
Yes, sir.
So if we calculate the period of this wavelength, if we calculate the time it takes AB, do you agree that that is the period of a wave?
Yes, sir.
Okay. But if they said AD, then it was going to be another issue. We were going to multiply our period by 2. Because it was going to take longer for the 2 waves to travel. I think you agree with me.
Yes, sir.
This will be 1 over, we were given that the frequency is 50 Hz. So 1 over 50, this will be, 1 over 50 is how much?
0.02.
0.02. Yeah, I'm also giving you a homework to go and master the units of each and every item in the formula. You must know all of them, because if you mess up with the units, you won't get the right answer. And what is the units?
Seconds, sir.
Seconds, perfect. Okay, calculate the wavelength of this wave. 1.2. This is 1.1. Calculate the wavelength of this wave. What is the wavelength of this wave?
It's 10 meters, sir.
It is how much?
10 meters.
10 meters. Okay, what is a wavelength?
It's the distance of two. It's the distance of 2 consecutive points that are in phase.
Distance between 2 consecutive points that are in phase. In phase on a wave. Okay. Now, what are those two consecutive distances that are in phase? Name 2.
It's B and C, sir.
B and C are in phase. B and C are not in phase. Points that are in phase, if you go to the points that are in phase and you draw the slope, it should be the same slope as the point that you are saying it is in phase with. If you draw a slope at C, it will be a negative slope. The slopes are not the same. But if you take A and B, these 2 points are in phase. I understand you can explain the definition of wavelength very well, but I don't think you have mastered the art of identifying the points that are in phase. These 2 points are in phase. A and B are in phase. And also, B and D, if you draw a slope there, it will be the same as this one. And also D and A, they're in phase. I don't know if you agree.
Yes, sir.
It's just that A and D, it's just that D is not consecutive. B is consecutive. So if you try to find the distance between the two, this will be your wavelength. Or if you are trying to find the distance between these 2 points, this is the wavelength. These 2 points are in phase. If you come and draw a slope, it will be a flat slope there on top, on both of them. So in order for 2 points to be in phase, they must have the same slope, and also they must have the same amplitude or the same displacement value. If you draw a slope on that point, it will be flat. But also if you draw a slope there, it will be flat. The slope will be 0. However, these 2 points, the displacement here is not the same as this one in terms of the signs. Upwards is positive, that's negative. Negative, positive. So these 2 points are in phase. These 2 points are also in phase. These 2 points are also in phase. And this one and that one in phase. So what is the wavelength?
Ten meters, sir.
10 meters divided by 2. 5 meters. Do you agree?
Yes, sir.
10 meters, it is the length of 2 waves. We have 2 waves in this case. If you check carefully, this is the first wave, and that is the second wave. Altogether, it's 10 meters. So per wave, how much do we have? We have 10 divided by 2, so it's 5. Do you agree?
Yes, sir.
Okay. Now calculate the amplitude of this wave. What is the amplitude of this wave?
It's 3 meters, sir.
1.4. You said 3 meters. What is an amplitude?
Max displacement from the position of rest.
From the position of rest. Where is the position of rest? Where is it? Is it here? Is this the position of rest?
Yes, sir.
Kumisa? No, it's not. The position of rest is in the middle. You agree?
Yes, sir.
So the amplitude is from the position of rest to the maximum displacement. So it is this distance. This is the amplitude. So what is the amplitude?
It's 3 meters, sir.
This is where the catch is. They always give you the full length because they know you're going to take it. And it's a trick. They are trying to trick you guys. It's not 3 meters. It's 3 divided by 2. Because it's from here to there. That's the amplitude. Are we together?
Yes, sir.
Okay, now point A and B on the wave in phase. Are they in phase?
Yes, sir.
Explain. Why are they in phase? You said yes. The first condition, same slope. We have to check a slope. We have to check the slope, and what is the second condition? Same displacement value. Same displacement value. The displacement at this point, at the point of rest, is what? It's 0. This is the point of rest. This is 0. If you go up, this will be 1.5. If you go down, it will be minus 1.5. And the distance between minus 1.5 and 1.5 is what? It is 3. Are we together?
Yes, sir.
Okay. Now they said calculate the speed of this wave. How do we go about that? The speed of the wave. Okay, what is the formula of calculating the speed of the wave in the first place?
It's
It's V.
V is equals to frequency times lambda.
The V. Okay. Then from there, they said must calculate the speed of the wave. Do we have the frequency?
Yes, sir.
It is how much? What is it?
Wasn't it 50 hertz, sir?
Perfect. Times the lambda.
5 meters.
5 meters, not 10 meters. So we will have 50 times 5, which is 55. What are the units of V, or the speed?
So the answer is 250.
It would be,
The answer is 250, sir.
oh, 250. Yes. Okay. Yeah, we can see. I said plus. Yeah. Okay. So it's 250. What are the units?
50. Isn't it
The
meters
units
per
of
second?
speed. Meters
Per second.
per second. Perfect. Now, do you have any question?
No, sir. Just to recap.
You sure?
Yes, sir.
Okay, so I'll do rapid fire questions. Okay. What is the units of lambda? What are the units of wavelength?
It's meters, sir.
What is the units of period of the wave?
Period, it's seconds, sir.
Seconds. Okay. Can sound waves move in a vacuum?
And which wave, sir?
Sound wave or longitudinal waves. Can they move in a vacuum? Can they move in a vacuum? The answer is no.
Yes.
Longitudinal sound waves cannot move in a vacuum. They always need a medium. And the medium that we're gonna be that we have talked about is air, water, steel, or any other material. And what we have said is that the denser the medium, the what? The denser the medium, the lower or the higher the speed. What is it?
Oh, it's low.
If you have a denser medium, will you have the higher speed of the wave or not?
I think it's going to be. I think it's going to be lower.
No, the denser the medium, the faster the wave, the sound wave. If you are dealing with a metal is denser than air, né? And therefore the speed will be faster than in air. The same thing with water. You told me that the speed of sound in water is 1,000 meters per second, right?
1,500, sir.
Yes, but in air is what? 300 and something.
Yes,
Water
sir.
is denser than air. Density is the heaviness of the material per cube. If you are given 1 cube of air and 1 cube of steel, steel will be heavier than air, and therefore the speed of the wave will also be faster because of the density. Are we in the same page?
Yes, sir.
All right. I think we don't have time anymore, so I will see you in the next lesson. Today is what? Thursday. So I'll see you on Tuesday. But also, I'm gonna try to give you homeworks which
Yes, sir.
you will submit on Google Classroom.
Yes, sir.
Yeah, so I will send the link so that you will submit on Google Classroom with Mahlatsi and few others if they decide to join. So I'll see you next week.
Yes, sir. All right.
All right. Cheers.